PreCalc Wednesday's edition 419. We're looking at probability, and I have to define for you independent events. So independent events is when one occurrence does not affect the other. Two events are independent if one does not affect the other. And the name bears that meaning. So independent events sounds like what it means. So if you roll a die, and what's the probability of getting a 1 and then a 6? We're talking about that today. The probability of rolling a 1 and a 6. Those events are independent. When I roll a dice, the first roll is not affected by the second. The second roll is not affected by the first roll. When I flip a coin, the two flips are not affected by one another. They are independent events. So, to calculate the probability of two independent events happening one after another or at the same time, this is what we do. Multiply so once again, to calculate the probability of two independent events happening one after another or at the same time, multiply. Or let me give you examples so you can see what I mean. Let's say that we have two independent events happening. The probability, say A and B, are independent. Events. One is not affected by the other. So the outcomes are independent. What is the probability of A, comma B? So it's always going to be multiply the probability of the first event times the probability of the second. So, for example, suppose I have 20 numbers in a hat. So here's my hat, and there are 20 numbers put in the hat. Hat contains 20 numbers 1 to 20, and each number occurs only once in the hat. So what's the probability if I draw from the hat? What's the probability of 3 draws are less than or equal to 5? So in each time I draw a number, I toss it back in the hat. So what's the probability that I draw 3 numbers each time I throw the number back in? What's the probability that each of those 3 numbers is less than or equal to 5? So each draw is independent from the rest, from the next. Each draw is independent from the next draw. And as long as I throw the numbers back in the hat each time, the one draw will not affect the next. So let's say the event is I want to draw 3 numbers. And I'm returning each time I draw a number, I return it to the hat. What's the probability that 3 draws are less than or equal to 5? So So we want to do the probability that with 3 draws we get less than or equal to 5, less than or equal to 5, and less than or equal to 5. These are my 3 draws. What's the probability of that happening? According to this principle, for independent events, you're going to take the probability of each draw and multiply them together. So what's the probability of drawing a number on your first draw from the hat, which is the draw creating a number or drawing a number less than or equal to 5? Well, how many ways can that happen? 1 through 5. And how many possibilities are there? 20. So 5 out of 20 is the probability of getting to meet this condition on the first draw. On the second draw, it's no different, and on the third draw. Alright, so these 5 over 20 is 1/4, so 1/4 times 1/4 times 1/4 is 1 over 64. So the probability of drawing from a hat with the numbers 1 through 20, returning the number after each draw, the probability of making 3 draws that create or selecting a number that's less than or equal to 5 is 1 out of 64. Alright, let's look at another example. Say 20% of the people in the U.S. get their news from the internet. Alright, with that in mind, let's choose 10 people from the U.S. at random. What is the probability that all 10 get their news from the internet? These events are independent because I've chosen randomly from the United States. That means that one person's choice of where they get the news is not affecting the next. They are independent of one another. So I've got 10 I've asked by the probability that all 10, I've chose 10. And that represents the 10. What's the probability that all of them get their news from the internet? Well, the probability that each person in the United States gets their news from the internet is 20%. So what's the probability that the first draw, that person gets their news from the internet? And the second. It's not affected by the first and the third and so on. So what do I do with all those numbers? Multiply. So we end up with 0.2 raised to the 10th. I'm not sure what that number is. I didn't do it on the calculator, but I know it's a very small. So 0.2 raised to the 10th. Let me see, I got it here. All right. 0.000001024. So very small probability of that happening. Alright, not sure how long this little explanation is taken. So I'm going to put the last example on another video. So see you in part 2.